HR of a reaction. Reaction enthalpy. The enthalpy change accompanying a reaction is called the reaction enthalpy. The enthalpy change of a chemical reaction is given by the symbol delta HR. Delta H reaction equals to sum of enthalpies of products minus sum of enthalpies of reactants. For the reaction, CH4 gas plus 2O2 gas giving CO2 gas plus 2H2O liquid. Delta HR equals to molar enthalpy of CO2 gas plus 2 into molar enthalpy of H2O liquid minus molar enthalpy of O2 gas. Let us study standard enthalpy of reactions. The standard enthalpy of reaction is the enthalpy change for a reaction when all the participating substances are in their standard states. The standard state of a substance at a specified temperature is its pure form at 1 bar. Standard conditions are denoted by adding the subscript V to the symbol delta H. Enthalpy changes during phase transformations. During phase change, temperature remains constant. Let us study standard enthalpy of fusion. The enthalpy change that accompanies melting of one mode of a solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion. Delta H not fusion. If a substance freezes, then process is reversed and equal amount of heat is given off to the surroundings. Melting of a solid is endothermic, so all enthalpies of fusion are positive. Let us study standard enthalpy of vaporization. Amount of heat required to vaporize 1 mole of liquid at constant temperature and under standard pressure, that is 1 bar, is called its standard enthalpy of vaporization or molar enthalpy of vaporization. Delta H not vaporization. We now study standard enthalpy of sublimation. Standard enthalpy of sublimation, delta H not sublimation, is the change in enthalpy when 1 mole of a solid substance sublimes at a constant temperature and under standard pressure, that is 1 bar. Sublimation is direct conversion of a solid into its vapor. Table for standard enthalpy changes of fusion and vaporization is shown. Let us study standard enthalpy of formation. The standard enthalpy change for the formation of 1 mole of a compound from its elements in their most stable state of aggregation, also known as reference states, is called standard molar enthalpy of formation. Its symbol is delta H not F. The reference state of an element is its most stable state of aggregation at 25 degrees Celsius and 1 bar pressure. For example, the reference state of dihydrogen is H2 gas and those of dioxygen, carbon and sulfur are O2 gas, C graphite and S rhombic respectively. Standard molar enthalpy of formation. delta H not F is just a special case of delta H not R, where 1 mole of a compound is formed from its constituent elements. By convention, standard enthalpy for formation delta H not F of an element in reference state, that is, its most stable state of aggregation, is taken as 0. Table for standard molar enthalpies of formation delta H not F at 298 Kelvin of a few selected substances is shown. Let us study thermochemical equations. A balanced chemical equation together with the value of its delta H reaction is called a thermochemical equation. We specify the physical state along with allotropic state of the substance in an equation. It would be necessary to remember the following conventions regarding thermochemical equations. First, the coefficient in a balanced thermochemical equation refer to the number of moles, never molecules, of reactants and products involved in the reaction. Second, the numerical value of delta H not reaction refers to the number of moles of substance specified by an equation. Standard enthalpy change delta H not reaction will have units as kilojoule per mole. We now see Hess's law of constant heat summation. Enthalpy is state function. Therefore, the change in enthalpy is independent of the path between initial state, reactants, and final state, products. In other words, enthalpy change for a reaction is the same whether it occurs in one step or in a series of steps. Hess's law. If a reaction takes place in several steps, then its standard reaction enthalpy is the sum of standard enthalpies of the intermediate reactions into which the overall reaction may be divided at the same temperature. In general, if enthalpy of an overall reaction A giving B along one route is delta HR and delta HR1, delta HR2, delta HR3 and so on, representing enthalpies of reaction leading to same product B along another route, then we have delta H reaction equals to delta H reaction 1 plus delta H reaction 2 plus delta H reaction 3 and so on. It can be represented as shown.